FlashTorch, shining a spotlight on the inner workings of neural networks. An open source toolkit built with PyTorch for neural networks in PyTorch. FlashTorch makes model visualization as easy as a function call. But before going into the demo, why is this useful? Feature visualization aims to understand how neural networks perceive images. However, implementing such techniques is often complicated. FlashTorch was created to solve this problem. Let's see it in action. Let me show you how to use one of the FlashTorch modules called Saliency. Saliency maps highlight visual features in images. By creating saliency maps, we can visualize what the neural network is paying attention to within input images. Okay, so first things first, install FlashTorch and make sure that it's the latest version 0.1. Then I'm going to import some utility functions to help me with the data loading and transformation. Also from FlashTorch Saliency module, import the backprop class which performs the call calculations to create saliency maps. Now I have two models that I like to visualize for the flower classification task, before and after the training. The starting model performed really poorly on the test dataset, whereas the trained model achieved over 98% test accuracy. Now, this sounds all great, but the test accuracy doesn't really tell you why the trained model is better. Is it even looking at the right features? To answer this question, I'd like to use this image of foxgloves and visualize what exactly these two models are paying attention to. With FlashTorch, you can visualize your model in 3 simple steps. First, create a backprop object with the model of your interest. Second, prepare an input image as well as class index that corresponds to the object within your input image. Now we're ready to visualize. Invoke a visualize method with the input image and class index as arguments. We can see that the starting model is paying attention to the general shape of the flower. But if you think about it, there are many flowers with the same shape. Let's see what the trained model is doing. Now that is very different. Instead of the shape of the flower, the model has learned to focus on the most distinguishing feature of this flower, which is the mottled pattern inside the flower cup. And this was all done with just a few lines of code.